This is Swati Ramya, Assistant Professor, ARDS Department. You are here with me in Operating System and Virtualization lecture series. In the previous class, we were discussing about the process and what is process and the process concepts. We were discussing what is process. Process is nothing but execution of the program. A single program can create an n number of process. Whenever the set of instruction in the program is executed, it will create the process. Suppose the same set of instruction, that is program, is executed 3 times. We have 3 process, and each process have its own memory and it has own stack. It has separate memory for each process. Okay, now in today's video, we are going to discuss about the components of the process. So let's discuss about the components of the process. Okay, a process is more, actually the program is a passive one. Process is an active one. Process is more than just a programming code. Okay, so if there is a program in a memory, it's just a set of instruction. It's just like a text in the text file, like that. But process is not like that. It's more than just a program code. Okay, program counter keeps track. We have a list of, let's see the components of the process. For each process we have a set of component. Okay, so let's see this components like that. Whenever you execute your set of instruction in the program, you can create n number of process for the same set of instruction. So the process have some few list of component. So let's discuss about these component. Process is not just a program code. It contains several critical components that the operating system must manage carefully to ensure the proper execution. So starting from the program code, CPU register, heap, program counter, stack, data section. As we already discussed in the previous videos, in the structure of process, we discussed the heap and the stack. So now we will discuss about the program code and other components of the process. Program code is nothing but it's a set of instruction that has been stored, that is in the program, that is called the program code. Next, about the program counter. Program counter will keep track of the next instruction to be executed. It will have the list of instruction to be executed next. It will have the address of the instruction which needs to be executed next. That address will be there in a program counter. Then about the CPU register, it stores the intermediate values during execution. When you execute the set of instruction, you have some intermediate values and it needs to keep track of these intermediate values and their addresses too. So for these things, the CPU register will be used. Actually, how it works is you have 2 process 1 and process 2. CPU is running the process 1, but suddenly CPU has to switch over to the process 2. So the process 1 will be in the waiting state and the CPU will be going to the process 2 and it started running the process 2. So but the process 1 is not run completely. It has been executed only partially. So until the execution, it has some intermediate values generated. So these values should be in keep track when the CPU will come back, switch to the process 1. The CPU register will have this set of intermediate values. So the CPU will take this intermediate values and it starts the execution from where it leaves. So that is the time the CPU register will be very helpful. It stores the intermediate value during the execution time. Okay, already we discussed about the stack and heap. It stores it supports dynamic execution and the memory needs when the execution is done. So OS has to manage all these components carefully to ensure the correct execution. If the set of instruction, that is the program, has to execute it completely, these component has to work properly. Only then the execution of the program will be done successfully. Okay, so let me give the simple example. When a function is called, the return address, when the function is called, you will have some return address, right? So the return address needs to be stored somewhere else. This return address will be stored in the stack, so that the program knows where the return address after the execution. This is how, whenever the switching of one process to the another process, or whenever it executing the function, and the return address or need to be stored in particular component, and all these component has to work together for the successful execution of the single program, which leads to the generation of a process. Okay.